A teacher informs his cellular biology class of 500 or more students that a test was very difficult, but the grades would be curved. Scores on the test were normally distributed with a mean of 40 and a standard deviation of 5. The maximum possible score on the test was 100 points. Because of partial credit, scores were recorded with 1 decimal point accuracy. Thus, a student could earn a 40.3 but not a 39.42. Okay, so first thing that I noticed when reading is that we have test scores that are normally distributed. So that gives me some clues as to how ultimately the problem will be solved. And in order to work through anything with a normal distribution, it's a great idea to organize the information on a bell-shaped curve. And that way you can just get a visual clue as to how to solve the problem. So the pertinent information for any bell-shaped curve is the mean and, of course, the standard deviation. So the mean is located right in the center of the distribution. And in this question, I am looking for if the top 11% will receive an A, what is the minimum score to get an A? So this axis, this 40, for instance, that's a score with relation to the test. So this axis is the score on the test. So I'm trying to find the score on the test. But all I know is that anyone who's in the top 11%, so if I shade what I feel is approximately the upper 11% of scores, that is the cutoff for students receiving an A. So anything below this value, you would have something lower than an A. Anything equal to or above, you would have an A. So we're trying to figure out what that cutoff is. Since that is a value that's relative to a unit of measure rather than a probability, so it's not asking for the probability of getting an A, it's asking for what value with respect to the other test scores will get you an A. We use inverse norm. And when using inverse norm, it takes 3 inputs. It takes an area to the left, it takes a mean and a standard deviation. So the area to the left, well, there's a problem here because the 11% is the area underneath the distribution's curve to the right. So we have to make a conversion. But that's actually not so bad. All we have to do is just take 1 minus 0.11. And if you need to get your calculator to come up with that, that's fine. Make sure you get the right value. That's all that matters. So 0.89. So that's what we're going to give as an input value to inverse norm. Has to be an area to the left. The mean is 40 and the standard deviation is 5. Now, when I go to use my calculator to get this value, I hit second and vars, which brings up the distributions menu, and I come down to inverse norm. Inverse norm, I give it my 3 inputs, 0.89, 40, and 5. And I come up with the minimum value to receive an A. So in this case, it's going to be 46.1. And I'm just giving an extra decimal place because it has sort of indicated that a student could earn something to the first decimal, but not the second. So that's the way I did my rounding, but follow any rounding rule that is given in the problem. Now, some of you may have seen a menu show up when you did the inverse norm, and that's okay. Some of the later model calculators do that instead, and it's just to help you remember what the input values to each function are. So the area provided is still area to the left. You just enter that. and then the mean and the standard deviation. Once you hit paste, it just takes those numbers and puts them in a comma-separated list right into inverse norm. So you'll get the same answers. Now, let's go to the next part of the problem. If the bottom 31% will receive an F, what is the minimum score to pass the class? Well, to do this, let's get a normal distribution drawn. Here's the mean of 40, standard deviation of 5 again. And we're looking for the bottom 31%. So the bottom 31% could be this amount of area here. But ultimately, we're looking for this boundary point for an F. But notice the only thing that's really different in this problem is the boundary for an F is the area to the left of the value. So if I do inverse norm again, it's already area to the left, the 31% that is, so I just give it as is. And then the mean and the standard deviation. So, using the calculator for inverse norm, 0.31, comma, 40 and 5. So 37.5.